Here we have a SAT math problem. Okay, let's go to the question. Okay, here we have a graph on the xy plane. The graph of function f is shown in the xy plane above. If length of MA of the rectangle MATH is 5, what is the length of AT? Okay, the length of this line segment MA is given, that is 5 units, and we have to find the length of this line segment AT. Okay, since the length of this line segment MA is 5, then the length of this line segment HT also must be 5, because both of them are parallel, so they must be having equal length. And also we have a value 5 on the y-axis over here, because the length of this vertical line segment is 5. We have number 5, positive 5 on the y-axis over here. Then what must be the y-coordinate of the point T over here? So the y-coordinate of the point must be 5. Then what must be the x-coordinate? That is unknown. We can assume k as the x-coordinate of this point. Okay, now we have to find the value of this x-coordinate k. For that, let me consider the function which represents a graph we have over here. Okay, in this function, usually f of x represents y. So we can rewrite the given function as y equals to negative x square positive 9. And we have this point k comma 5 and the graph of this function y equals to negative x square positive 9. Since we have this point on this on the graph of this function, we can plug in the x coordinate k for x over here and y coordinate 5 for y over here. Let me do it. Then we have 5 equals to negative k square positive 9. Okay, now let's solve for k in this equation. For that, I have to subtract 9 from both sides. When I subtract 9 from both sides, positive 9, negative 9 will cancel out. 5 negative 9 is equal to negative 4 equals to negative k square. Now, to get rid of the negative sign we have in front of k square, we can multiply both sides of this equation by negative 1. When I multiply both sides of this equation by negative 1, I am getting 4 equals to k square. Because when I multiply this negative 4 by negative 1, it will become positive 4. When I multiply this negative k square by negative 1, it will become k square. Now, to get rid of this square, what I have to do is I have to take square root on both sides. Whenever I take square root on both sides of an equation, for one of the square roots, I have to consider positive or negative sign. Usually, we consider positive or negative sign for the square root which contains number inside. This square root contains number 4 inside, so we can consider positive or negative sign for this square root. Then we get positive or negative. Square root of 4 is just 2. On the right side, the square root and square root cancelled, we just get k. Okay, I'm getting two values for k. One is k equals to negative 2 and the other one is positive 2. Okay, here we can replace this k by positive 2. So because we have this point on the positive side of x-axis, so we have to consider the positive value of k. And also we can consider the negative value of k, that is negative 2. So that we'll have over here at this point a, that is negative 2 comma 5. Okay, since the exponent of this point a is negative 2, so here at m we have negative 2 on the x-axis, and here exponent is 2 at the point t. So at h the value of the x-axis has to be positive 2. Okay, here we have negative 2, here we have positive 2. What is the length of this line segment? It's just 2, because here we have negative 2. And what is the length of this line segment? This is also 2, because here we have 2 on x-axis. What is the length of the line segment MH? That is 4, because here we have 2, here we have 2. So the length of the line segment MH is 4. Then what is the length of the line segment AT? That is also 4, because MATH is a rectangle, then AT and MH are opposite sides, so they are parallel and also they are equal in length. So whatever length we have for the line segment MH, the same length we have for the line segment AT over here. So therefore the length of the line segment AT is 4. We find 4 in answer choice D. The correct answer choice for this question is D.